Auzubillahiminash-shaytanir-rajim. Bismillahir-Rahmanir-Rahim. Dear student, Assalamu alaikum. My name is Dr. Muslim Khan, Assistant Professor, Department of Chemistry, KUST. Today, the topic of our discussion is hyphenated technique, gas chromatography. Is in hyphenated technique, either the HPLC or gas chromatography or electrophoresis or some other techniques are basically combined to the mass spectrometry or some other technique. So today, before going to discuss the gas chromatography connected to a mass spectrometer, we will discuss the gas chromatography. Then the combination of gas chromatography with MS. The course code is CHEM453, mass spectrometric and thermal method of analysis. First of all, gas chromatography. Gas chromatography is a chromatographic technique that can be used to separate a volatile organic compounds. Once again, this is a chromatographic technique that can be used to separate volatile organic compounds. What are the different components of a gas chromatography? It consists of a flowing mobile phase. A flowing mobile phase in case of HPLC, that is in a liquid form, but here in a gas chromatography, that's why it is called gas chromatography, because the flowing mobile phase is usually gas. And then an injection pot where you are injecting your sample. And then every chromatographic system have this column, which is the heart of the chromatography, a separation column, the stationary phase, on the basis of which you are separating different components. And an oven, this is an additional thing in gas chromatography rather than, and while in HPLC, this is a missing, this is not there in the HPLC system, an oven. I will tell you what is the function of oven. And then finally, when something is coming out of this column, this must be detected. So a detector. This is the flow chart of a gas chromatographic system. Here you can see this is a cylinder having this mobile phase. So this mobile phase is flowing through the system from this gas supply system. And here in the path of this mobile phase, this gas, injection port where we are injecting our sample. Sample is having different components, different compounds. We are separating those components or compounds in the GC system. So this is the column of the GC chromatographic system. This column is seated in the oven. This is a thermostat oven which control the temperature of this column. So you can increase or decrease or keeping constant the temperature of this column. So then when this effluent is coming out of the column, then it is going to the detector, and also this whole system is connected to the recorder where it is recorded. This is how, this is the inside of the GC chromatographic system, which look like. This is the cylinder. With this cylinder, this is filled of your mobile phase gas, either argon or helium. This is the regulator of this mobile phase. You can control the flow of this mobile phase. And here you are, this is the injection port where you are injecting your sample. And then this is the column of the GC chromatographic system. Usually this column is very long, and this column is placed inside this thermostat oven, which you can control the temperature of this thermostat oven. And then this uh, sample which you have injected here, along with mobile phase, when passed through this column, this is coming out of the column and it is going to the detector where it is detected, and then it is connected to a recorder where you can record your chromatogram. On the table, this is how typically GC system look like. This is lying on the table. So this is a GC system. This is also another model of a GC system, and this is GC210 gas chromatograph. This GC system is connected to a cylinder having a mobile phase, either argon, helium, and this is also having here a cylinder or here a cylinder. So this mobile phase is coming from this cylinder. Here it is here this automated system of HPLC system, which you are entering this, which you are inserting your sample, and then here the column of this chromatographic, the own chromatographic system in which column is there. So it then further subjected to the detector. This is how a GC system look like. What is the principle of a GC system? The organic compounds in a mixture are separated due to differences in their partitioning behavior between the mobile phase, mobile gas phase, and the stationary phase in the column. So the organic compounds are separated due to differences in their partitioning behavior between the mobile gas phase and the stationary phase in the column. So some of the component having more interaction with the stationary phase, so it will stay for a long time on the column, while some of the component having less interaction with the stationary phase will go fast with the mobile phase, and it will be eluted first from the column. So mobile phase are generally inert gases such as helium, argon, or nitrogen. So that inert gases, so that mobile phase is not interacting or not reacting with your components to be separated. The injection port where you are injecting your sample consists of a rubber septums through which a syringe needle is inserted into the inject the sample. So an automated sample injection system. So this rubber septum through which this needle is inserted from this injection system and inject the sample to the system. And the injection port is usually maintained. This is very important. This injection port is usually maintained at a higher temperature than the boiling point of the least volatile component in the sample mixture. The injection port is maintained at a higher temperature than the boiling point of the least volatile component in the sample mixture. Since the partitioning behavior is dependent on temperature, the separation, since the partitioning behavior is dependent on temperature, the separation column is usually contained in a thermostat controlled oven. So where you can control the temperature of the column, you can increase or decrease or even keeping constant the temperature of the column. Separating components in a mixture with a wide range of boiling point is accomplished by starting a low oven temperature and increasing the temperature over time to elute the high boiling point components. So it means that in a GC system, you have to program your GC system according to the increasing temperature. So initially you set the temperature at a low, and then with time, you already program your GC that with time the temperature is increasing over time to elute the high boiling point component. This is the oven of the gas chromatographic system. This is a thermostat oven where you can keep the temperature constant, where you can increase or decrease the temperature of the oven. So the inside this oven there is a long column. There is a long column of GC system. So this is showing the capillary column. This when mobile phase coming with your sample is passing through this column. Some of the components are retained more and some are less. On the basis of this retention behavior, partitioning behavior inside the column, the different components are basically separated and then further subjected to the detector. So in summary, we can say that this is a sample having different components. Here it is represented by a blue color, yellow color, red color, green color, etc. When this sample along with mobile phase in a GC system is subjected to the column, is flowing through the column, a gas flow like with helium. So some of the component like blue are retained more by the stationary phase, having more interaction, while some are less, like this red have a very less interaction with your stationary phase, and this red will be eluted first and the blue will be eluted last, and this is having not very having a great interaction, not very less interaction. So these will be eluted in the middle of the time. So this when coming out of the column are detected by a detector, and then you get this chromatogram, which chromatogram is basically the plot of different components relative abundance versus time. So this some like this is time in minute. Some components are eluted at 10 minutes and some at 20 minutes and some at 25, even 40 minutes and 60, 55 and 60 minutes, etc. So this is how chromatogram look like. For example, you are separating hydrogen, oxygen, nitrogen, and methane. So when these gases, so this hydrogen have a different interaction with capillary column, and oxygen have different, and nitrogen have different due to the chemical behavior, and methane different. So and chromatogram like this is a 12 second. This is a 16 second, 24 second, and 32 or 34 second. So this is how chromatogram of these gases will look like. When this effluent, these components along with mobile phase is coming out of the column, is going to the is going to the column. So column is the most important part of the any chromatographic system. There are two types of gas chromatographic column: packed column and capillary column. Packed column, this is a typically a glass or stainless steel coil, 1 to 5 meter total length. The length of this column is 1 to 5 meter, and the inner diameter is 5 millimeter, very thin. This is filled, this 1 to 5 meter column is filled with stationary phase or a packing coated with the stationary phase. On the other hand, capillary column is a thin fused silica, typically 10 to 100 meter in length, very lengthy in comparison to this, and 250 millimeter inner diameter. Stationary phase coated on the inner surface of this capillary column and provide much higher separation efficiency. in comparison to packed column. But this column can be more easily overloaded by too much sample. So when this effluent is coming out of the uh, gas column, then it is subjected further to the detector. So after the components of a mixture are separated using gas chromatography, they must be detected as they exit the GC column. Thermal conductivity detector, which is called TCD, and flame ionization detector are the two most common detector on commercial GC. The most two common and frequently used detector in GC system is TCD, thermal conductivity detector, and flame ionization detector. The other detector include atomic emission detector, AED, chemiluminescence detector, electron capture detector, ECD, flame photometric detector, FPD, mass spectrometric detector, and photoionization detector. The requirement of a GC detector depend on the separation application. For example, an analysis may require a detector selective for chlorine containing molecule. Another analysis might require a detector that is non-destructive so that the analyte can be recovered for further spectroscopic analysis. You can't use flame ionization detector in that case because it destroys the sample totally. TCD, on the other hand, is a non-destructive detector. What is TCD detector? A TCD detector consists of thermal conductivity detector of an heated wire, electrically heated wire. The temperature of the sensing element depends on the thermal conductivity of the gas flowing around it. The temperature of the sensing element depends on the thermal conductivity of a gas flowing around it. Changes in thermal conductivity, such as when organic molecule displace some of the carrier gas, causes a temperature rise in the element, which is sensed as a change in resistance. The TCD is not sensitive as other detectors, but it is non-specific and non-destructive. While electron capture detector, this is the effluent coming from the column, uses a radioactive beta emitter electrons. This is the source, source of this radioactive beta emitter to ionize some of this carrier gas, this mobile phase gas, produces, when ionize means ejecting out of electron. So ejecting out of electron means the flow of electrons. So it produces a current. Produces a current between biased pair of electrodes. This collector electrodes in the electrode. So when organic molecule and the component that contains electronegative functional group such as halogens, phosphorus, and nitro group passes by the detector, this electronegative group captures some of these electron from this flow of electron, so it reduces the current. That reduce in current is basically measured. That's why it is called electron capture detector. And the next one is flame ionization detector. This consists of hydrogen and air flame and collector plates, hydrogen and air flame, and this collector plates. Collector is something nut with insulators inside on wall. So the effluent from the GC column passes through the flame, through this flame, break down organic molecule and produces ions. The ions are collected on these biased electrodes and produce electrical signals. This, this electrical signal is basically measured, extremely sensitive electrode and a large dynamic range. The next one is MS detector. As we are discussing hyphenated technique here, so this GC is connected to mass spectrometer. The other detector of GC like flame ionization or which is set it inside this GC system is we turned it off basically. So we are connecting this GC system to MS detector. So uses the difference in mass to charge. You already know about mass spectrometer. So ionized atoms or molecule to separate them from each other. Molecules have a distinctive fragmentation pattern, that provides structural information to identify structure components. The general operation of a mass spectrometer is it create gas phase ion, separate the ions in a space or time based according to their mass to charge ratio, measure the quantity of each ion to mass to charge ratio. So the separation power of a mass is described by the resolution of the mass spectrometer. R is equal to M divided by delta M, where M is the mass and delta M is the difference in mass between two resolvable peaks in the mass. For example, an MS with a resolution of 1000 can resolve an ion with a mass to charge ratio of 100 from an ion with a mass to charge ratio of 100.1. Thank you very much. So here are these are the books which you can find these material. J.D. Christian, Analytical Chemistry, 7th edition, Scooge and West, Fundamental of Analytical Chemistry, 9th edition. And thank you very much.